Hi, my name is Przemysław Grabowicz, and I'm heading the Socially Intelligent Media and Systems Lab at the College of Information and Computer Sciences. Hi, this year we witnessed the storming of US Capitol by an angry mob. These events turned out to be closely relevant to the information technology industry and to computer science because, as we could see, soon after they unraveled, multiple social media companies banned President Trump and his followers from the platforms. In this way, the social media companies have shown the power they yield. However, with great power comes great responsibility. These companies have put this responsibility on the users by banning President Trump and his supporters. However, they also admitted that the activity in social media platforms have contributed to the events at the Capitol. And so the question whether social media design have contributed to the polarization of the users of social media have contributed to these events is a valid one. In order to try to address this question, let us step back a little bit. In the last 25 years, the news industry has changed dramatically. Newspapers have gone online. Multiple social media companies have emerged. The ad revenue, major source of income of those companies, have plummeted, whereas the market capitalization of social media companies have skyrocketed. The digitalization of the news industry has brought a lot of positive changes to the society. First, the news industry is more transparent nowadays and more accessible. Second, multiple research opportunities have arisen thanks to the digitalization of news industry. For instance, if you go to the Google Scholar and type Twitter and search for papers that mention it, it turns out that 7 million papers have been written in the last 13 years since the appearance of Twitter. 50 of those papers have been co-authored by me. News articles have received less research attention so far than social media. However, there are a couple of platforms that crawl and process news articles worldwide. Media Cloud was created at the Berkman Klein Center for Internet and Society at Harvard University and co-founded by my dear colleague Ethan Zuckerman. We are collaborating with Media Cloud. Media Cloud stores about 2 billion news articles already from last several years. It crawls about nearly 1 million of news articles nowadays. One of the big problems in this space that we are trying to address is what do we do with these news articles? How can we cluster them into meaningful news events? It turns out that this problem is a fundamental problem in machine learning because we do not know a priori what classes, what news event clusters there are. In fact, the partition into clusters, into news events, changes over time. And the additional challenge here is that there is no labeled datasets of semantic similarity between news articles. We plan to address these issues. For instance, we plan to develop the first labeled dataset of multilingual news articles and their semantic similarity. The digital revolution in the news industry may have had a wider societal impact. For instance, we can observe that linguistic and international societal divides have diminished in the last years, and this is correlated with the emergence of platforms such as Facebook that span multiple countries and languages and enable automatic translation of the content posted in these platforms. However, the societal divides along other dimensions, such as political and racial dimensions, have widened, as it is exemplified by the events at the Capitol. Not only that, but the ban on Trump's account, and the accounts of his supporters have led to an influx of users from mainstream social media platforms to alt-right platforms such as Gap and Parler. What kind of changes has the digitalization of news industry brought to news media platforms? Well, about 15 years ago, the comment threads have started to appear in online editions of newspapers. Here you have an example from New York Times. Not only comments, but also likes on this comment and dislikes on these comments appear nowadays in most of digital editions of newspapers. These features are well known for social media platforms such as Facebook and Twitter, where multiple times of social interactions appear. Not only that, but there are machine learning algorithms running on these platforms that optimize for engagement. Multiple studies have shown the impact of social signals on our perception. Here I'm showing the screenshot of an experiment that we performed on YouTube, where we were showing YouTube videos to the participants, except that they didn't know that we changed the social signals that were shown underneath the video. We changed the number of thumbs up, thumbs down. We also hid some of the comments, either positive comments or negative comments. And then we asked the participants whether they liked the video. And this is what we are showing in these figures. On the y-axis, you see the probability of liking the video. On the x-axis, you see the difference in the positive and minus negative comments that the participant read underneath the video. And it's clear that the probability of liking the video depends on the comment that the participant read underneath the video. Now, these results are for content that have a subjective dimension to itself, but similar results have been shown for factual content as well. In news platforms, claims about facts appear all the time. However, news outlets oftentimes have biased audiences. For instance, here you see an article from National Review, which is a right-leaning news outlet. Then, the responses from the users, from the audience, are also biased towards the right-wing perspective. That's understandable. However, this leads to reinforcement of echo chambers. This leads to the situation when the two groups from both sides of political spectrum reinforce their untrue beliefs through social signals that they leave in social media. Here you see an example of that in a recent publication, where the researchers find that there is a correlation between the propensity of users to follow sources of information and their partisanship. This problem could be addressed by debiasing the social signals that appear underneath news articles and making them representative of the overall US population instead of just the given audience of the given news outlet, independently whether this is a left-leaning or right-leaning news outlet. Tools necessary for such debiasing are already available. Here I'm showing an example of an early study in this space of political stance identification. Our lab works, among others, on the problem of demographic attribute inference. Here, for instance, we infer gender and age of Twitter users. And foremost, social media platforms such as Facebook have already hundreds of attributes for their users. These attributes are used on ad targeting platforms of the social media. For instance, here you see a screenshot from the Facebook ad targeting platform. You can see multiple categories of user attributes, including demographic interests and behaviors. However, social media currently uses these attributes only for ad targeting and not for decreasing polarization. Do social media companies have the incentives to profit common good? I'm not sure. Here, one of my students conducted an experiment where he created a Twitter poll and then he went to one of the many external websites where one can buy fake Twitter or social media interactions in general. He bought there 100 votes to his poll, and you can see that these votes are included in this screenshot. So Twitter shows them as if they were just organic votes. The surprising part is that if you click on the details of this tweet, so if the producer of this tweet tweets on the details, then the producer will see that the number of organic votes that were casted in this poll is just 2. It doesn't include the fake interactions. So that means that the Twitter is in fact able to distinguish between fake interactions here and organic interactions. However, it decides to show publicly both fake and organic interactions together without specifying that this poll may have been manipulated. This shows why research in this space is so important. We shall identify social media designs for the common good because social media companies may be slow to do so. So far, I've shown that manipulation of social interactions can be addressed with transparency. Misinformation and polarization could be addressed with nudging users towards representativeness. Now, one other challenge that both touches social media platforms as well as other platforms is discrimination. Data sets used for learning machine learning models may be tainted by discrimination. This is a concern relevant not just to social media platforms that employ various learning algorithms for various purposes, but in other contexts as well, for instance, in tools predicting recidivism in US courts. Here, the problem is to develop learning algorithms that are resilient to discriminatory shifts in a training dataset with respect to a test dataset. To this end, we can use protected attribute, for instance gender, from the training set. I'm going to show you some results from an image classification task where we encode the protected attributes with these markings, blue and green markings, placed in the corner of images. And the result of this is that the cross error, which is basically the error of the model with respect to the non-discriminatory ground truth, decreases for our method, which is drawn here in red, with the marker size. Also, the impact disparity, which is a measure of discrimination for a model, also diminishes with the marker size. The interesting part is that the concept of resilience isn't just important for fairness in machine learning, but also it is important for open world learning. Here I'm showing a screenshot from the game Angry Birds. Initially, the player plays with the red bird, shots with the red bird, and wooden blocks, ice blocks. This is the first 10 levels of the game in different configurations. Later, a blue bird is added. Then there is also a TNT block added, and the agent has to adapt to these additions. Now, the concept of resilience is central to understand an agent's response to environmental changes such as new object types. High resilience is crucial for learning from few samples, which is standard for humans. This is the reason why me and the KDL lab, led by David Jensen, are collaborating on this problem, among others in the domain of Angry Birds. Furthermore, it turns out that here the number of classes is also known, because when we start to play Angry Birds, we don't know how many types of birds there is, for instance. So this ties back to this first problem I discussed at the very beginning of this presentation of use clustering, even though the domains are entirely different. Finally, I would like to thank all the incredibly smart and delightful people I've been able to work with both the members of the KDL lab that we've been closely collaborating with, and the members of the SIMS lab, headed by me, who have contributed to this presentation. Thank you for your attention.